This is a practice exercise from page 314 of the textbook. We're talking about atoms that can exceed their octet. So they give us a couple of different atoms: sulfur, carbon, phosphorus, and bromine. And if you look at those atoms, carbon is in period 2, so it's using its second energy level. Phosphorus and sulfur are in period 3, so they're using a third energy level, and then bromine is in period 4, so it's up to a fourth energy level. So atoms that can exceed their octet are found in the third energy level and higher, and there's a couple different reasons for that. The first reason is how big they are, allows them to accommodate extra electrons, and the other reason is that they have d orbitals available once they get to that third energy level, because that's where 3d starts. So because of that, anything in the second energy level or above is only going to be able to form that standard octet. Third energy level and below is going to be able to exceed. So that means that carbon is never going to be found exceeding its octet, because carbon is only in that second energy level. It has no ability to exceed it. Okay, using this information, let's try to draw a Lewis structure. So again, when we draw Lewis structures, we want to figure out which elements are involved. In this case, we've got xenon and fluorine. We want to find them in the periodic table and think about how many valence electrons they're bringing us. So if you look at xenon, it's a noble gas, which means that it is going to bring 8 valence electrons. It should seem a little strange that we're making a compound with a noble gas, but there are a few noble gases that have been found to bond, so this is fine. And then we have 2 fluorine atoms, each of them bringing 7 valence electrons, so that brings us up to a total of 22 valence electrons. We're going to start just like we always do by building our skeleton. Central atom is the first atom, so xenon's going to go in the middle. Going to put our skeleton in, a fluorine atom on either side. So that cost me 2 electrons for one bond, 2 electrons for another bond. So I've used a total of 4 electrons so far. Now I'm going to complete the octet of the atoms on the outside. These are electrons 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Well, since I've completed the octet for everything on the outside, but I still have more electrons, I just put them on the center atom. So I was at electron 16, so this is going to be 17, 18, 19, 20, 21, 22. So now I've used all of my electrons. And this is something interesting to point out, that I only use double bonds or triple bonds when I run out of electrons. If I have too many electrons, I just put the extra ones around the central atom. So let's see what's going on with our octets. So if you look here at fluorine, fluorine has 6 non-bonding electrons, 2, 4, 6, and it's sharing 2 more. So fluorine does have 8 electrons around it. Fluorine's fine. Same thing for the other one, 2, 4, 6, 8. This fluorine's fine. If I look at the xenon in the center, I see that it's got 2, 4, 6 non-bonding electrons as well, and then 8, 10 total valence electrons. So is this an appropriate Lewis structure? Well, I know that fluorine is in that second period, the second energy level, so fluorine cannot exceed its octet, but xenon can. Xenon is far enough down in the periodic table that xenon can exceed its octet, so this is a valid Lewis structure. Even though we do have more than 8 electrons around the central atom, this is possible for xenon, so it's fine.